The roots or solutions of a polynomial are its x-intercepts. The x-intercepts occur where y equals 0, and that's why we set our quadratic equation equal to 0 when we're solving. At this point, you have learned how to solve quadratic equations by factoring, using square roots, and completing the square. So let's take a look at another one. All right, so we have a standard form of an equation, and we're going to solve for x using completing the square. All right, so we're going to look at completing the square for this problem. Now, this is some generic equation. Right, so a and b and c stand for numbers. They're constants. We just don't know what constant they are. All right, so our first step when we're using completing the square, and we have a coefficient in front of x squared, we have to divide by that coefficient. All right, so we're going to divide everything by a, because we have a coefficient in front of x squared. Okay, so a, of course, would cancel in our first term. So we have x squared plus b divided by a, x. All right, so those are just two constants, right? Any two constants at all. Plus c divided by a equals 0. Our second step is to move the constants. So we're going to subtract c over a from both sides. All right, so if we subtract c divided by a, we're going to have x squared plus b divided by a over here. And of course, we're subtracting from both sides. So over here, we're going to have a negative, right? So this is going to be negative c divided by a. And now we don't have any constant term on the left-hand side. So now if we're doing completing the square, remember, we have to take b, divide by 2, and square, and add that to both sides. All right, so b divided by 2 squared, I have it right over here. So our b term is b divided by a. That's our b term. If we want half of it, right, we want to divide b divided by a in half, right, we'd multiply that by a half. So dividing by 2 is the same as multiplying by a half. Right, so b divided by a times a half gives us b divided by 2a. And now we have to square. So we're going to square both of them. Right, so we've got b squared, and then 2a squared would give us 4a squared. So now we're going to add to both sides b divided by 4a squared. I'm going to do the same thing over here. So equals negative c divided by a plus b divided by 4a squared. Right? So now we can factor over here. We still follow the same format, right? So it's going to be x, that's plus, so it's going to be plus, and it's always b divided by 2. Well, what was b divided by 2? It was the thing we had before we squared it, right? It's b divided by 2a, right? So half of b divided by a is b divided by 2a. So this is going to be b divided by 2a. And of course, we would have 2 of them, so that means that's squared. So now we need to add our terms over here, and they're not like terms right now because they don't have the same denominator. Right? So our least common denominator, we've got a 4, and we've got an a squared. Right? So a divides into 4a squared, and 4a squared divides into 4a squared. Right? So we're going to have to change c divided by a so it has 4a squared as its denominator. And what is it missing? Well, it's missing a 4 and it's missing an a. Let me keep with my green, right? So it's missing a 4 and it's missing an a from the denominator. So I'm going to multiply the numerator and the denominator by 4a. Right? If I do that, I now have a 4a squared in the denominator, and I can combine the like terms. In the numerator, that's a negative c. Negative c times 4a would give us negative 4ac. I just put the terms in alphabetical order. I could have just as easily had it negative 4ca. All right, so let's simplify that right-hand side. We have x plus b divided by 2a squared equals, and now we're going to have negative 4ac and that's going to be over 4a squared. Right? So that's just from the starred step, number 5 right there. I have the work over there. Right? So we'll just use that work. And then plus b divided by 4a squared. Well, now I can combine those two terms. So I've got x plus b divided by 2a squared. We've just been carrying that along. That looks like a 29, doesn't it? Equals. All right, so now that's going to be, and I'm going to just rearrange the ordering. Right, so if I add them together, right, this is going to be, where shall I put it? I'll put it right here. If I add them together, I have negative 4ac plus b. But I don't really want the, and then it would all be over 4a squared. Right, so we're adding fractions with the same denominator, right? We add the numerators. I just don't like the ordering of that because I've got a negative to start with. I kind of like it better like this. I'm going to put the b first. It's the same thing. I just changed the order. So b minus 4ac. Right? So b is still positive, and 4ac is still negative, all over 4a squared. All right, so now we're going to solve, because our whole goal was to solve for x using completing the square. Right, so we're going to take a square root of both sides. And so on this side we have x plus b divided by 2a all squared equals, right, and we're going to take the square root of that one. Of course, don't forget plus or minus, right, because these are all constants. They may look like letters, but they are standing in place of a specific constant. X is a variable. It can take on any value, but a, b, and c are specific constants. It just doesn't matter what constants they are. When we're trying to prove something, we want to make sure it's true for every constant, not just certain ones. Right? So if I use a, b, and c, I'm proving that this is true for all constants. All right, so now I'm going to take the square root of b minus 4ac. Now remember, when we have a quotient, we can split this into two radicals. And I've got 4a squared in the denominator. All right, so on the left-hand side, the square and square root will cancel. It's getting a little crowded over here. I could extend the page. Yeah, let's do that. I think the only thing you're going to lose, oh, look at that. I didn't even lose anything. All right, so square and square root will cancel. We have x plus b divided by 2a equals. Nothing you can do with that numerator. b minus 4ac, that is not a perfect square. However, the denominator is a perfect square. Square root of 4a squared is going to be 2a. I'm going to go this direction, so I have lots of space on the left, on the, excuse me, right-hand side. We have one last step here. Our goal was to solve for x. So we have to subtract b divided by 2a from both sides. So, and I shouldn't put an equals, I'll just put an arrow. Right, so we're going this direction now. And this is my last step. So x is equal to, so if I'm subtracting b divided by 2a, I have negative b divided by 2a, plus or minus the square root of b minus 4ac divided by 2a. Now I'm looking at those two fractions. Right, we have two fractions there, and I notice they both have the same denominator, so we can combine them into one. Right, so x is equal to negative b plus or minus the square root. My b on the step above looks so much like a 6, but that is a b. b minus 4ac, all divided by 2a. And now we have solved for x in this problem. Not only have we solved for x, we have, in this particular problem, we now have a formula that we could use in other problems. The reason we can use it in other problems is we've proven it's true all the time. We just did completing the square, something we know, and a technique we can use with some random constants. That's why it was important that it didn't matter that these were just any old constants. If I had used a number, all I would have proved is that I could use it for that particular problem. In this case, I've proved I can use it for every problem, and now we have another formula that we can use to solve quadratic equations. This particular formula is based on completing the square. That's where that formula comes from. It comes from using completing the square with ax squared plus bx plus c. It's important that you know how that formula was derived. right? You shouldn't really use a formula that you have no idea what those terms mean, or where it came from, or why we would ever use that formula, right? You should have some background in every formula you use in math. So let's take a look at our formula. So solving quadratic equations with the quadratic formula. The solutions of some quadratic equations are not rational or not real and cannot be obtained by factoring. For such equations, we can either use completing the square or the quadratic formula to solve for x and find the roots or x-intercepts of the parabola. Some of our solutions won't be x-intercepts. They'll be x-intercepts if our solution is a real number. If we have a complex number, we have an I in our solution, then it's not going to correspond to an x-intercept, but it will be a solution. The quadratic formula is derived using ax squared plus bx plus c and completing the square. And so here we have our quadratic formula. The solutions of ax squared plus bx plus c equals 0. Of course, a can't be equal to 0. Otherwise, we wouldn't have a quadratic formula. We'd have something linear if there's no x squared. Is given by x is equal to negative b plus or minus the square root b squared minus 4ac divided by 2a. Right? And if you think back, if you have trouble remembering it, if you kind of think back to these steps that we did, you'll see why the whole term in the numerator there is divided by 2a. Remember, we combined those like terms because we had used completing the square. Notice the plus or minus symbol. That means the formula breaks into two parts. Right? So you have to show there's two solutions. That's why there's a plus or minus. And we're going to simplify as much as possible. And let's take a look at this problem. I'm going to do one problem before I end the podcast. All right, so we're going to solve using the quadratic formula. We first need to determine the values for a, b, and c. So our equation must be in standard form. X squared, then the x and the constant equal to 0. And we have that. And so once we have that, we can identify our a, b, and c. And let's set up the quadratic formula. All right, so x is going to be equal to, I'm going to write the formula before I plug in, negative b, and it's always a good idea to write the formula so you don't make an error, plus or minus the square root of b squared minus 4ac, all divided by 2a. So x is equal to, so we have a, b, and c already identified, negative 7. So I have a negative 7. That's going to make this a positive 7, right? Because b is already negative. So if I take the opposite of a negative number, it's positive. So 7 plus or minus the square root of negative 7 squared. Don't forget to square the negative there. All of b is squared. Minus 4 times 6 times negative 3. All divided by 2 times 6. So x is equal to 7 plus or minus. We've got 49, and we have two negatives there. Right? So we got 4 times 6, going to be 24, and then 24 times 3 is going to be 72, but that's going to be a plus 72. Because we have two negatives, so be careful on that. And divided by 12. All right, now you got to simplify. So we have x is equal to 7 plus or minus the square root. So that's going to be 121. Do not leave your answer like this, because you must simplify as much as possible. When you use completing the square and you isolate x, and unless you've got numbers that you can just add, and two real numbers that it can be added and subtracted together, you're going to be as simplified as you can be. With quadratic formula, you sometimes have to simplify. 121 is a perfect square. Square root of 121, that's 11. So we have x is equal to 7 plus or minus 11 divided by 12. This is also not your answer because this could be simplified. All right, so we need to split our fraction. We need to split this into the plus and the minus. So we have our two solutions. We have x equals 7 plus 11 divided by 12, and x equals 7 minus 11 divided by 12. And you always must split that. All right, now, if this could be simplified no further, like say I had 7 plus or minus the square root of 11, that would be fine. But I can simplify 7 plus or minus 11 further. All right, so 7 plus 11, that's going to be 18 divided by 12. Well, that could be reduced. They're both divisible by 6. All right, so 18 divided by 6, that's going to be 3, and 12 divided by 6, that's 2. So 3/2 is our solution. 7 minus 11, that's negative 4. That could be reduced. They're both divisible by 4. So negative 4 divided by 4 is a negative 1, and 12 divided by 4 is 3. So notice we have real and rational solutions. Well, if you have rational solutions, you have to have real solutions. If you get real and rational solutions, it means you could have factored. Let's take a look at this and factor it. All right, so notice how many steps it took us. Let's factor. All right, so A is 6 and C is negative 3. 6 times negative 3 gives us negative 18. We need two numbers that multiply to give us negative 18, but add to give us our B term of negative 7. Well, that's good. There's not that many factors of 18, and the one we're going to need is negative 9 and 2. Right? They multiply to give us negative 18. They add to give us negative 7. We're going to replace that negative 7x with a negative 9x and a positive 2x. So we have 6x squared minus, that was supposed to be a 9. There we go. Minus 9x plus 2x, and we keep the negative 3. So keep the first and last. You're only replacing the middle. And I could use a wee bit more space. There everybody goes. Everybody move over. You move over too. There we go. Equals 0. The first two are a group. The second two are a group. There has to be a plus, right? Because all we're doing is we're still addition. We still have terms that are added together, added or subtracted. We're just grouping them into two separate groups. Once we have two separate groups, we can factor out a greatest common factor. For greatest common factor for 6x squared and negative 9x, that would be 3x. If we divide 6x squared by 3x, we would have 2x. If we divide negative 9x by 3x, we would have a negative 3. Greatest common factor for 2x and negative 3, well, that's going to be a 1. That's their only common factor. So we can factor out this repeating factor. Both of our terms, 3x times 2x minus 3, and 1 times 2x minus 3, have a factor of 2x minus 3. If we factor out a 2x minus 3 from both of those terms, we're left with a 3x and a positive 1. Now we just set those equal to 0. 2x minus 3 equals 0. X is 3/2. 3x plus 1 equals 0. And x is going to be negative 1/3. Right? I would subtract 1, divide by 3. On the other one, I would add 3, divide by 2. Right? I tend to do that as one step. And you can too, if you can do that last step in your head. And there we have it. We could have factored. So be careful. Don't always rely on one method, because for different problems, some methods are going to be better than others. And some methods you can't use at all. So for instance, we couldn't use solving by square root at all. Factoring took us a little less time and effort than did the quadratic formula. And we had probably less opportunities to make a mistake. For instance, if you did not notice the two negatives with the negative 4 and the negative 3, you were definitely going to get a wrong answer. Right? So you have to be careful when you use quadratic formula. In the next set of lessons, we're going to solve problems using quadratic formula and completing the square and see which one took us less steps. Right? You don't always want to go to one method as your go-to method. You want to choose the best method for the problem. Thanks for watching this podcast, and I'll see you in the next one. Bye for now.